Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, Mr. T here with a tutorial today on polynomial division. In this tutorial, we'll be reviewing doing long division of polynomials. We'll talk about a shortcut version of that division called synthetic division, which we'll be using most of the time, and it's useful for when we're dividing a polynomial by a linear factor. We'll talk about two algebra theorems called the remainder theorem and the factor theorem. They tie together the polynomial division with finding the factors or zeros of a polynomial. And finally, we'll work through an example of using these theorems to fully factor a polynomial. Before we get into working with polynomials, we need to review some math from your grade school days. We need to learn how to divide this manually. Many of you are used to using the calculator for dividing these, but if we were back in grade school doing this, remember we would be setting up our divisor, and then we would use this symbol for our division. And under that symbol, we write the number that we're dividing. So since I have 3 digits here, I'll be going in 3 digits and finding and putting here the biggest number of times that this number divides into 376. So let's try 3. Now we multiply this number times this and we get 369. And we subtract here. So if I subtract, I get 7. We then bring down this number, bring down the 8, and we try to divide, but 123 does not divide into 78, so we have a 0 here. Now we bring down this next number, 9. So now 123 divides into here. Let's try that. It's probably almost, it's probably 6 times. So 6 times 3 is 18, 12, 13, 6, 7, 38. And we subtract again, so we get 1 here and a 5, 51. Bring down the 0, and now we divide here. 123 will go into that about 4 times. So we get 4 times 3 is 12, 8, 9, and 4. And we subtract and we get 18, which is our remainder. So 123 did not divide evenly, and we could write the result as our quotient here, this number, and then the remainder we put over what we were dividing by. So this is our mixed number result when we do this division. So now we're going to do the same process but using polynomials. So we're going to use this. So we're going to set it up just the same. So we're going to write our divisor and then our divide symbol. Now when we put the polynomial, well, both this polynomial and this polynomial, if there are any missing terms, any missing powers, we have to fill those in and put a coefficient of 0. So if this had been just x squared plus 2, I would have had to put plus 0x here. So you've got to have a term for every power. You can't have any missing terms. So on this one, we're missing the x squared, so I have to write that to look like this. So I have to write in here 0x squared. If you don't fill all of the places, then the division is not going to work properly. Again, you have to have all the places here. Now we've got 1, 2, 3 terms here, so we're going to go in 3 terms here. And on this, we're just going to check the leading terms here and divide. So 2x to the 4th divided by x squared is 2x squared. Now we're going to multiply this times this just like we did before. So 2x squared times 2x squared is 2x to the 4th. Here we get negative 4x squared, x cubed. And plus 4 x squared. And now we have to subtract, just like we did. So when we subtract, we want to subtract this whole polynomial, so I've got to change the sign of all of these terms. And now since I distributed a minus through, now I can add. So that cancels out. We get 0. Here we have 7x cubed. Here we have minus 4x squared. And now we bring down the next term. So x squared goes into this 7x times. Now we're going to multiply the 7x times all of that. Now I have to multiply by -1 here so that I can subtract. So now I have that cancels out here. So we have 10x squared minus 9x. And I bring down my -1. And this divides in 10 times. So now we've got 10x squared minus 20x plus 20. And we are now going to, again, multiply by a negative so that we can subtract. So now we're adding since I've multiplied by the negative. So we have here 11x minus 21. That's our remainder. So our final answer would be written as 2x squared plus 7x plus 10 plus, and then the fraction or the rational function divided by what we originally divided by, but here the divisor, and this here is our answer. Now what we're primarily looking for when we divide polynomials is trying to get a remainder of 0. So we're going to talk about why we want that or why we're looking for that in a bit. Now most of the time we will be trying to factor polynomials, and we'll be looking to find what are called linear factors. And when we have factors that are of the form an x with no number here minus a number, we can use a process called synthetic division. Now just off to the side here, if we were dividing by x plus 3, that's still in this form. That would be x minus a -3. So just like we've done with a lot of things where we have like x minus h, whatever, we're going to be taking the opposite of this number. Now to set this up, the number that we're going to put outside the divide symbol is the value that makes this parenthesis 0, which is going to be k. So if I set that equal to 0 and solve, I get x equals 2. This is my k. So I'm going to put that here. I'm going to kind of make an upside down divide symbol. And just to make sure I don't miss anything, what I'm going to label up here are, starting with this highest exponent, I'm going to count down. So these are going to be all the exponents that I need to have in my table here. And what's going to go under those exponents? So these are our exponents. And what's going to go under each of those exponents is the coefficient, meaning the number in front of the term, for that power of x. So in front of the x cubed is a 1. In front of the x squared, there's a missing x squared, so the coefficient is 0. The coefficient in front of the x is -7, and the exponent of the 0 is the constant term, so that's -6. Now to do the synthetic division, so notice here, this is opposite of here. It'll always be the case. We bring down our first number. And now what we're going to repeatedly do is multiply what's down here. The last number we put down here, we're going to multiply times this number and put in the next slot over. So 1 times 2 is 2. And then we're going to add. Now I'm going to repeat that process. 2 times 2 is 4. And then we're going to add. -3 times 2 is -6. And I'm going to add. Now we have to interpret these numbers. This last number here is our remainder. And these are the coefficients of our quotient, or our result. And they are going to be 1 degree less, because we took here x cubed and divided it by x, so we're going to be getting an x squared. So this is the coefficient 1 degree less than this. So in this case, it's going to be x squared plus 2x minus 3. And then our remainder, which again we put as a rational function, over what we divided by, which was x minus 2. So this is our result of this division. Now I'm going to do another one of these in a minute when we do our last example, so you'll get a chance to follow that process one more time. Now the reason we're doing this division is we're going to make use of these two theorems. So the first theorem says if we divide a function f of x by a factor x minus k, so a linear factor where we have x, the remainder we get from the division is the value of that function at the value here of k, meaning if I had plugged k into the original function and calculated, I would get the same thing as I get when I divide. So if we go back to our last example, if this is our f of x, if we evaluated f of 2, we're going to get negative 12. So if I put positive 2, if I put positive 2 here, I've got 2 cubed minus 7 times 2 minus 6. This is 8 minus 14 minus 6 equals negative 12. So the value here of f of k was the same as the remainder we got. The second part is how this ties in is that something is a factor of a function if and only if we get a remainder of 0, or another way of saying it is if we evaluate f of k, we get 0. And again, this is going to be the remainder of our division. Now this ties into what we were doing when we solved quadratic equations. Remember, we set the y value, which is the function value, equal to 0 and solved. So let's kind of tie this together, our synthetic division and those theorems. So we're trying to find, is x minus 2 a factor of this polynomial? For that to be the case, two things have to happen. So f of 2, which is our k, has to equal 0. So that's what we're trying to find out. And to find that out, we can find out if I divide x cubed minus 2x squared minus 9x plus 18, if I divide it by x minus 2, is my remainder 0? So this is a linear factor here, so we can use our synthetic division. So let's set that up. So remember, we take the opposite of this number and goes outside of the divide symbol. We make our kind of upside down divide. And our coefficients here, and I'm just going to label these so we don't forget one. So the coefficient of the x cubed is 1, coefficient of the x squared is negative 2, the coefficient of the x is negative 9, and the coefficient of the power of 0 term, which is the constant term, is 18. Remember, we bring this first number down, and now we repeatedly multiply and add. So 1 times 2 is 2. And we add, we get 0. 0 times 2 is 0. We add, we get negative 9. Negative 9 times 2 is negative 18. And we add, we get 0. And remember, that number is our remainder. So since we got a remainder of 0, our theorems tell us that the answer to the question, is x minus 2 a factor? The answer to that is yes. And we also, since x minus 2 is a factor, this is what's left over. So we have also determined if we take x cubed minus 2x squared minus 9x plus 18, that we can factor out an x minus 2. And what would be left over would be this. Remember, this is since this was x cubed, this is x squared minus 9. And now that is a quadratic, and we know how to factor quadratics, so that factors into x minus 2 and x plus 3 and x minus 3. So as we're using this synthetic division, we will be, for higher order polynomials, finding through a variety of means some number of factors, and once we are able to get the polynomial by doing synthetic division down to an x squared, then we can use all the factoring rules that we learned in the last unit on factoring quadratics. So I hope this helps, and good luck with your dividing. See you soon.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you